Hi students, welcome in chemistry classes. I am Priyanka Jain and you are watching videos of English. So today's lecture is from the analytical chemistry about the chromatography. In this lecture we will see what is chromatography, how we do the classification of the chromatographic techniques, and then we will see thin layer chromatography, one of the very important technique. Okay. In our last lecture we have studied about the solvent extraction technique. Okay, and we know that there are several lectures, very important lectures that I have already made, okay, on the analytical chemistry like polarography, like thermal analysis methods. So you can also watch that lectures if you want, right? So let us start the chromatographic techniques. First of all, understand what is the chromatography. So see here, this chromatography term has been taken from the two Greek words, okay. In Greek, chromatos means color, and graphos means writing or written. It means whenever anything is written with the help of color, then this is called the chromatography. Okay, chromatography means writing with the colors. So actually what is happening here, we are doing here the analysis of the different types of the substances present in a sample. Okay, with the help of the chromatography, we are separating out different types of the substances present in a sample, and these substances will give different lines, different type of colors. Okay, so actually we are taking any column. Firstly, when this technique was developed, we are taking here the column. Okay, this technique was firstly done in the column. So here we have seen different types of the band of the colors. So this technique was called chromatography technique. Actually, firstly this technique was given by Michael Sweat. This technique was given by Michael Sweat. In his experiment, Sweat would have done, he had taken the extract of a leaf, a plant leaf. He took its extract firstly, and he made its solution in the petroleum ether. So this was a leaf extract solution in the petroleum ether. Then he passed it through a column. There was a column like this, okay, and in this column there was calcium carbonate present. This is the column of calcium carbonate, right? This was a column, and he poured this leaf extract in this column. Okay, he poured this extract in this column, and then he passed a pure ether solution in it. Okay, then he poured pure ether here. So what happened, firstly he have taken here the calcium carbonate in a column, then he poured here the leaf extract in the petroleum ether, and then he poured pure ether, passed pure ether through the column, as a result of which various chlorophyll pigments get separated out in different color zones. We get here different type of color zones like this, okay, and these chlorophyll fragments get separated like this. Okay, these are the different color zones. So in this way, the chlorophyll pigments get separated in different color zones. So this technique was called chromatographic technique. Actually, it is a very important technique. This technique is used for separation, isolation, purification, and identification of components. Different types of the components can be separated, can be isolated, can be purified, and it can be identified. So I think this thing is now clear. So firstly understand what is the basic concept behind the chromatographic technique. Actually, in chromatographic techniques, the separation is done by the distribution of the component between the two phases. There are actually two phases. One phase is called the fixed phase. This phase will remain fixed throughout the procedure. Okay, so it is called fixed phase. And another phase is moving. Okay, this is moving phase. So we are calling it mobile phase. But actually there are different names for them. This fixed phase is actually called the stationary phase. And this moving phase is called the mobile phase. So actually in chromatographic techniques, there are two phases, stationary phase and mobile phase. In whole the chromatography techniques, whatever technique you are seeing here, in all the techniques there are two phases. One is stationary phase, one is mobile phase, and these phases are different for different techniques. Okay, so these techniques has been classified, but actually in basis the phases are two, stationary phase and mobile phase. So the basic concept remains the same. What happens in this stationary phase our sample is present. Okay, the sample is present in this stationary phase, and then this mobile phase is poured. Okay, it is passed through the column or any other thing that we are taking. This mobile phase is passed through it, so that what will happen, this sample will get distributed between these two phases, stationary phase and the mobile phase. This whole thing depends upon the fact that this sample is held on which of the phase more strongly. Suppose this sample component, any of the component, if it is strongly held by the stationary phase, then it will remain in the stationary phase, and if it is more strongly bind by the mobile phase, then it will go with the mobile phase. Okay, so different type of the sample components will have the different affinity for the stationary phase and for the mobile phase. So what will happen, there will be the separation of the components. Okay, so this is the whole principle of the chromatographic techniques. Alright, now see the classification of the chromatographic techniques. Chromatographic techniques actually can be classified in the different manners. We can classify them on the basis of phases. Solid liquid chromatography. In solid liquid chromatography, one phase is solid and another phase is liquid. And actually, this stationary phase will be solid. The stationary phase will be solid, and the mobile phase will be liquid. Next, another may be liquid liquid chromatography. In liquid liquid chromatography, both the mobile and the stationary phases both are liquid. And the third type may be liquid gas technique or gas liquid. It is also known as the gas chromatography. Okay, both are the same things, liquid gas or gas liquid chromatography. Here the stationary phase will be liquid and the mobile phase will be gas. So this is on the basis of the phases. But we can also classify the chromatographic techniques on the basis of the principle or the mechanism of the extraction. On the basis of mechanism of extraction, these techniques may be, first may be adsorption chromatography. In adsorption chromatography, the stationary phase is solid. The stationary phase here is a solid phase. This solid phase may be either alumina or it may be silica gel. The solutes are absorbed in different parts of the adsorbent column. The adsorbed components are then eluted by passing the suitable solvent. Okay. Firstly, we are taking here a stationary phase. Okay, this is alumina or the silica gel, and our sample is present here. Okay, sample is present here. So that what will happen, the different components of the sample will get absorbed on this phase. Okay, according to their absorption nature, their affinity of adsorption. Right, some of the parts will get absorbed more strongly and some of the components will get adsorbed less affinity. Okay, and then we are passing the mobile phase. Okay, we are passing a suitable solvent, that is called the mobile phase. So here the mobile phase is a suitable solvent. This is also known as the eluent. In chromatographic terminology, we are calling it eluent. And this process of passing the mobile phase through the column is called the elution. Okay, this process of passing mobile phase is called elution. So what happens after the elution, when we are passing this mobile phase through this stationary phase? So what will happen? Some of the components will have more affinity for this mobile phase. So they will get absorbed on the mobile phase with more strong affinity. Okay. So these will come with the mobile phase and they will pass through the column. So they will get separated, and some of the components will have more affinity for the stationary phase, so they will remain in the stationary phase. In this way the different components get separated out. Okay, one of the technique of the adsorption chromatography, one of the most important technique that we see in the adsorption chromatography is the column chromatography. Column chromatography is one of the very important type of the adsorption chromatography. Whenever we are using a column, okay, whenever we are using a column, then this technique is called the column chromatography. One of the important example of this type is the HPLC technique. Okay, we will see that in our later lectures. I will also make a lecture on the HPLC technique, so you will see that full technique in that lecture. Okay, just here we have taken the example. Another important type of the technique for the adsorption chromatography is the thin layer chromatography that we will see in this lecture. Okay, in the end of this lecture, we will see thin layer chromatography. So in the adsorption chromatography, in total we can say in adsorption chromatography, the solute separates based on their ability to adsorb on the solid stationary phase. This whole technique is based on the method of adsorption. How strongly any substance it get absorbed on the stationary phase or on the mobile phase, right? Second technique is the partition chromatography. As you can see from the name, this technique, the principle of extraction, the principle of separation is partition. Partition means how the substance can distribute itself between the two phases. This is called the partitioning. Okay. So in this method, what is happening? Here the stationary phase is a solid support coated with thin liquid film. So this will make our stationary phase. Any solid support, we are coating it with the thin layer film. Okay. So this will make our stationary phase. And our mobile phase will be any suitable solvent. So basically our sample is present in the stationary phase. Okay. And when we are passing the mobile phase through it, when we are doing elution by this mobile phase, what will happen? This sample components, the sample that we are taking will partition itself between the stationary phase and the mobile phase. And this whole thing depends upon the difference in the equilibrium partitioning of solute components between the liquid stationary phase and the mobile phase. Okay. Any component may have more affinity for the stationary phase, other may have the more affinity for the mobile phase. All the components will have the different affinities so that they can be separated out, right? Now see the third technique. The third technique is called the ion exchange chromatography. A very important technique. This is a very important technique. I will also make a lecture on this technique so you can see this ion exchange chromatography. Stay with us. I will make lectures on all of the chromatography techniques separately. So see all the lectures. So third important technique is the ion exchange chromatography. Here the stationary phase is a solid support, but there is one difference. There is also solid support, but this solid support is covalently attached anionic or cationic functional groups. It means in this type of solid support there are anionic groups and the cationic groups. Okay, anionic groups means like sulfate group is present here. Okay, sulfide group, or cationic species like NCS3 whole thrice. This group may be present. Okay, so such type of groups are present here. So what happens? These our solutes are actually here. Our sample is a ionic solutes. This will have ionic components. So these components will divide them in this. Okay, our solid support may be anionic or may be cationic according to this ionic solute. So they will adsorb themselves on this. They will form actually the electrostatic forces with them. Okay, there is not absorption. Absorption technique is different. There is only the electrostatic attraction between this solute and this resin. Okay, this is the electrostatic force. So they get attached to it by the electrostatic forces of attraction, and they are forming bonds here, right? Now we are passing the mobile phase. So what will happen? Some of the solute components are more strongly attracted on the stationary phase, and some of the components are less strongly attached. So the substances that are less strongly attached will come faster. Okay, so in this way we can separate out them. The fourth technique is size exclusion chromatography. Size exclusion chromatography is somewhat different. Here we are using the porous gels as the stationary phase. So here our stationary phase is porous gels. Okay, porous gels are used as the stationary phase. Okay, so now the separation is done by the difference in the size of the solutes. Okay, so here the principle is what? Principle is difference in size of solute components. Different components will have different size. So they will get penetrate this porous gel in different manner. The larger solutes are unable to penetrate this porous gel. While if we are seeing the smaller solutes, they will easily penetrate, right? So the smaller solute will enter into the porous stationary phase and thus increasing the time spent on the column. Okay, while the larger solutes will spend lesser time in the column, so they can be separated easily on the basis of their size, right? Now see our one of the important technique, that is thin layer chromatography. Okay, thin layer chromatography is also known as TLC. Okay, TLC is a special technique of adsorption chromatography. So basic principle here is what? Adsorption. So this technique is called adsorption chromatography. This technique is adsorption chromatography. Here we are taking a glass plate coated with a thin layer of adsorbent. Okay. What is our stationary phase? Our stationary phase is here a glass plate coated with a thin layer of adsorbent. Okay, the thickness of layer will be approximately 0.2 mm. Actually, this TLC technique separates the component mixtures on the basis of their polarity. Okay, actually our stationary phase in general, when we are taking this stationary phase is a silica gel. This silica gel is coated on a glass plate, and our mobile phase is sample solution. So now the sample is present in mobile phase. Our mobile phase is sample solution. Okay, one thing is clear here. First of all, our stationary phase is a glass plate that is coated with a thin layer of adsorbent, and our adsorbent is silica gel. It means we are making a coating of silica gel on the glass plate with the thickness of 0.2 mm, and mobile phase is a sample solution. So now see what is happening here. See here, in this method what we are doing, see, this is our plate. Okay, I am making roughly, you can see in the books. So this is our slide. Actually we are taking a slide here. Okay, and on this we are making a coating of silica gel. This glass plate is coated with silica gel uniformly. Okay, actually we cannot do uniform coating, so we take a ready-made slide with the coating of the silica gel. This you can easily purchase from the market. You will get a slide of the glass with the coating of silica gel. Okay, now what we have to do, we have to take a drop of the sample solution. Okay, and we have to put here. Okay, we are putting here a tiny drop of the sample solution, and we are making a line with the pencil. Okay, like this is the line that we have drawn from the pencil. Okay, now what you are doing, you are taking a beaker. Okay, in this beaker the solvent is present. Okay, this is the solvent. Now we place this slide somewhat above this. Okay, in this manner, this is arranged with the help of some support. Okay, in this manner, this is any support by which this is placed here. Okay, so what will happen, this will be like this. Okay, in this manner, this solvent will not touch this drop. Okay, this drop will remain, this point will remain somewhat above this solvent solution. Okay, and then after some time what you will see, that this solvent is getting rise. Okay, this will look like this. After some time you are seeing that the solvent has been risen by the capillary action. This is the line of the solvent. This is solvent line, and we are making here a line with the help of the pencil. We are marking this solvent line. Okay, this is the solvent line, and with this solvent what is happening, at the same time sample components get separate about, why? Due to different polarity. These will have different polarity. Okay, so they will get separated, and you are getting lines like this. Okay, these are the components. You can see here, these are the components that get separated out. Why they get separated out? Because some of the components will have the more polarity and some will have less polarity. So what happens? The more polar sample components will move less due to the polar nature of the silica gel, and the less polar sample components will move more. Okay, so they get separated out. Okay, we can write here, more polar sample components moves lesser. Why they are moving lesser? Because they will form attractive bonds with the silica gel, because our silica gel is polar. Okay, so there will be polar attraction, right? But the less polar sample components moves faster. Okay, so in this way they get separated out. Now what we have to do, we have to measure their distance. Okay, and we are using one term that is called RF term. RF term. This RF is called the retardation factor. Retardation factor, or we can call it retention factor. The retardation factor is called the relative adsorption of each component of mixture, and this is given by the formula RF is equal to distance traveled by component A divided by distance traveled by solvent. Okay, so you can measure the distance traveled by the solvent. We know about the solvent line, we know about the distance of the different components, so we can also measure them. In this way we can find out the RF values. When we find out the RF values, this values actually ranges from, these RF values ranges from 0 to 1. Okay, as the RF value increases, as the RF value increases, the retention of the solute decreases. Okay, this RF value changes with the time of migration, adsorbent and the solvent. Now we can check this RF value from the reference list. You will have a reference list in the laboratory. You can find out that list and you can check the RF values with the reference list, and then you can find out which type of component is present. Okay, if your spots are colorless, if you are finding the spots that are colorless, then you can see them with the help of the UV light. Okay, so in this way the whole method is done. Okay, so this is all about the thin layer chromatography. I have give you whole the concept in very short manner, because very detailed things you does not need. Okay, I have given you all the vital topics. Okay, and if you want some more topics, if you have any query, you can comment me, right? In our next lecture we will study about the column chromatography technique, a very important technique. Okay, so stay with us, and if you are liking my videos, you can comment me, you can like the videos, you can share the videos, and you can subscribe our channel. So I hope please subscribe the channel and give us a lot of support. Thank you.